Steve Rutherford, how's it going?
How's it going, Dan?
Pretty good. Thanks for sending out the call for agenda items last week.
Uh, didn't get anything, but I did send out the call for an agenda.
Yeah, well, it makes people aware of it.
Hi, good morning, good evening.
Hey,
Hi, Ella.
Elena.
Hello.
Hey, Jörg.
Hey, Jorg. People still seem to be trickling in, so we'll give people another minute or so, and then we probably should get started.
Good, because I needed one more minute to think through this RM minus RF before I hit it.
That has never gone wrong before.
Yep. Accidentally blow away the rest of my coworkers' scripts.
I feel like the classic is when you RM-RF and then realize that you've bind mounted or something your way into deleting your whole file system.
Yeah.
All right. I think we should probably get started. So I'm going to be taking notes, or at least attempting to, in the associated notes doc. I sent it out over the email. I'll paste it into the chat for this thing as well. I believe kind of the main thing that we will likely want to talk about today is the OS to SBSM interface and how that goes back and forth. We had some discussion last time. I feel like we did not come to any concrete conclusions. So I think I'll open the floor first for anyone who has a concrete thing to start with here, or even necessarily just questions or things that they want to try to make sure that we close on over time, perhaps through this meeting, or perhaps through other means. So I guess I'll open the floor here and see if anyone has things to bring up.
Yeah, so maybe I can start. So we continued this discussion in the SVSM community in some of our calls, and what actually people came up with was that we want to go down the route of having kind of a virtual bus implementation and a SVSM bus implementation in the Linux kernel, which then uses different architecture or platform-specific backends to basically talk to the SVSM. But from the Linux side, on a high level, it would look like a bus which can have devices, for example, a TPM device or an observability device or a live migration device or whatever, or what people come up with in the future. So that's kind of what we concluded in the SVSM community. So maybe James or Stefano have something to add here.
No, not really. I mean, doing a bus device doesn't get us out of not doing an SVSM interface, which I thought was the question Intel was still unsure on.
I guess.
Right, but yeah.
No, just to say
Go
that, like, you know, if we get an agreement with maintainers and we understand how it will look like, I think, you know, the interface is kind of somewhat easier part of it, at least in my view.
Well, so my thought of the SVSM bus is that it would look somewhat like the way KVM does its KVM bus, except KVM does bit banging of registers that KVM knows to look for in VirtIO. We wouldn't do that. We just do SVSM calls. And so it would be broadly similar apart from the communication mechanism. Although technically an SVSM call is really nothing but a bit bang and, you know, a register that tells you where the buffers are.
With KVM bus, are you referring to VirtIO bus?
Yeah, sorry, the VirtIO bus, the one that KVM uses.
No, I was a bit confused. Thank you.
Well, the reason it bit bangs it is because it looks fairly similar to a PCI bus. PCI buses do a bit of bit banging. And KVM has the ability to sort of set watches on various areas, so it can pick up the bit bang. Part of our problem with the SVSM is we don't really do that, so we can't. Which is why we have to use either the GHCB or MSR protocols to effectively bang the bits.
One thing, the VirtIO bus or whatever is built on top of it will be asynchronous. By asynchronous, I mean vCPU would be doing something else, but the current bus which we are using, GHCI, GHCB or whatever, so CPU itself exits and corresponding stuff is done on different layers. So just from design point of view, I don't know if that will help, because do you want vCPU to go ahead or run something else, or I think we want vCPU to halt till this thing is serviced by another layer.
Well, so that's very similar to the way VirtIO does I/O mapping, which would cause a VM exit. I mean, memory mapping, you're right, doesn't. So we just look like an I/O map bus because we always exit.
Okay, you're saying that with VirtIO we will do same thing, the synchronous thing.
Only for the I/O mapped case, but it can do both. So, but for memory mapped, it does exactly what you say, but we can't do that because we have to take a VM exit for the communication protocol.
Yep.
So we look like the IO mapped case.
Yep. And the benefit which we want to achieve is the vendor agnostic thing, not the asynchronous thing. Yep.
Yeah, so the idea that under the bus implementation itself, there's an API with exchangeable backend implementation. So there can be one for TTX, there can be one for SNP, there can be one for other Cocoa architectures in the future where the SVSM runs on. Yeah, so that's kind of the idea. So we define a set of operations that we need for the bus, and then every platform can implement it in a way that fits the platform best.
How to do the discovery? I mean, how to link a driver to a device? I'm thinking about, for example, for AMD, could be the SVSM protocol number. But should we think something generic depending on the platform?
Well, so the way VirtIO does it is it just has a set of IDs. It actually has a vendor and a device ID. It never uses the vendor ID. The device IDs are just assigned starting from 0. If you wanted to be a bit more clever, we could do something that still fits into 4 bytes, like a 4-byte letter coding of it. But I don't see any merit in one over the other. Problem with doing the protocol number is, what if we get a protocol that wants multiple devices or something?
But this will work with AMD, right? If what we will have different drivers for different. I mean, for example, I'm thinking about the TPM for the AMD SVSM and maybe a TPM for the Intel. They will be different drivers, so maybe we have different numbers.
Why would they be different
Wow,
drivers?
yeah, I have the same question.
Okay, so for Intel, they will reuse the same protocol number defined by AMD spec?
Well, this is a device that's attaching to the SVSM. It doesn't matter what technology brought it up. The SVSM is emulating it. Somehow the underlying confidential computing technology is communicating with the SVSM, and the VTPM is brought up on Linux that corresponds to the one in the kernel.
Yeah, it's a virtual bus and virtual things.
Yeah, it's completely agnostic to the confidential computing technology. We should be able to use the same driver even on ARM and RISC-V.
So only transport part would be different, ideally.
Yep, and we're supposed to be hiding the transport part deep in the architecture section, so it's not visible stuff above it, like the VTPM driver.
Okay, yep.
But then the TPM itself would know what the underlying architecture is, right, to establish trust in itself, right? So that's a TPM specific problem, but still. Or is that something that's sort of completely outside of this bus interface?
You mean TPM driver or TPM inside SVSM?
The TPM inside SVSM.
Oh yeah, but that one is different. Yeah.
Yeah, that's probably independent of the actual bus and the transport being used. So
yeah, that has to operate on SVSM and understand what it runs on, and how to operate, how to talk to underneath hardware, and requests whatever it needs to request. So I think we say are pretty split up from whichever.
Yeah, right.
I think it's something similar. In Virta.io, they have different transport like Virta.io, MMIO, Virta.io, PCI. So maybe it's very similar to that, right? So it doesn't depend on the transport. The ID is the same on every transport. So
Yeah, so I was envisaging we do that differently. The VirtIO transport is done in the ops thing. And I think we need to abstract all out of the way so it's hidden even from the bus itself, because it needs to occur deep in the architecture layer. So I was thinking we'd look like we use a single transport and then let the architectures decide how it's done.
Yeah, I would agree with that. So I think this would complicate if we start to expose the transport on the bus level.
Yeah, because in our case we cannot never have multiple architectures, right, at runtime. Maybe with Virta.io you can have both Virta.io PCI and Virta.io MMIO. So maybe this could be the reason. But anyway, okay, I get it.
For clarity, I think I did send an email out a while ago, like I promised to, and it did describe the differences in transport. And now I have to find it, I presume.
I guess like maybe one question I can ask is like generically, like if you know if we're in agreement that this would be, you know, at least the approach which could be, you know, tried out, do we have like enough details or like, you know, high level understanding of a design to go ask, you know, x86 maintainer opinion checks? Because this is really still something which worries me the most. Maybe I'm alone with this worry, but
Everyone fears the x86 maintainers. You should really write this up and get it to them. And I think what we came up with is a pretty clean design. I actually don't expect much opposition, maybe some questions, but yeah, we'll see. We need to write it up anyway and send it their way. Or we wait until some small patches materialize and discuss on that. I'm not sure if anyone, Stefano or James, have you started on trying to implement this?
Not yet. I don't know if James had time, but still try to finish
Well,
the.
you said you wanted to take first cut, so I think we've got ourselves into one of these positions where each of us is waiting for the other, right?
Yeah, I mean, I want to take a look, but didn't have time. So I can try next week and then we can sync. But if you have time, let me know.
I will do. I mean, I think, unfortunately, this is partly to do with community politics. We're sort of, the care and feeding of Jaakko Sakainen is a bit difficult. And Stefano looks like he's got it done. If I start on saying, oh, we're going to do this completely differently, there may be a different reaction.
Okay, I will continue. I'm not sure if try to merge the current version of the TPM. At least we have something that runs, and then we can try to extend it with the bus, right?
Well, that's what I was thinking. It wouldn't be, I mean, it's just basically the discovery mechanism. And the reason we give is because we want a discovery mechanism that's architecture agnostic. And so we're going to use an SVSM bus.
Yeah, I completely agree. We want to remove the platform stuff and whatever. So, okay, let's continue in that direction. I will try to merge the current TPM for AMD SVSM, and then we can try to extend it to support, to be platform independent.
Yeah, I mean, I wouldn't have advised this course of action, except that getting anything upstream in the TPM subsystem is really, really difficult. And it looks like we're almost there.
I'm I'm seeing that.
So it sounds like the best approach is to wait for the patches and then discuss based on the patches, right? It's probably not too far out.
Right.
Well,
So
I can post the patches simultaneously. The problem is we don't want to disrupt the current upstreaming of the TPM driver.
Right. That makes sense. So
yeah, so I would
in the
say
use,
let's try to merge the current TPM and then post the patch to change it.
right, yeah, that's a good approach. That makes sense. So the use cases I have in mind for the SVSM bus besides the TPM are not that urgent, so that can wait. So merging the TPM driver is certainly more important than that.
Just a question, what kind of other devices we have in mind to support, to use that kind of bus?
Well, the
So
observability devices.
right, that was the one that started the discussion. From as I said, from the Linux kernel, you want to have some visibility into the SVSM, what it's running, and what does the log file says, and what and stuff like that. Also probably about resource usage. So that's one use case, or one device that you're probably going to expose. And one other thing I had in mind, but I haven't discussed it widely yet, is some sort of live migration device where basically which allows the guest OS to decide whether it wants to be live migrated or whether it wants to shut down and restart somewhere else. So based on, so this device would basically tell the guest OS, hey, there's a request to live migrate you to this target. Here's the attestation of the target. Do you agree with the live migration or not? And then the OS can decide what it wants to do.
Yeah.
Well, we're probably actually going to have a device that replaces the current sev guest attestation as well, because even TDX will require attestation of the VTPM.
Yeah, right. Yeah. That would definitely change in this scenario, right? So
Yeah, but we don't have to do that immediately. We don't have TDX yet, so we can switch attestation away from sev guest as soon as we have another one that's budding for upstream.
Yeah, I agree on that.
so this were the two use cases I have in mind, but I'm sure people come up with more so over time. Or UEFI, we were also talking about this variable store thing that would also be some kind of device.
What was the last one? Sorry, variable.
There was a proposal for doing the UEFI variable store in the SVSM
Oh, all right. Now I remember.
to basically have a trusted variable store and not have it on the untrusted hypervisor side, or even a volatile variable store. I'm not sure where the efforts for that are, but this was another proposal that was brought up.
Joanna is asking what's our takeaway. I guess the takeaway is that we wait on patches, right? And then have a discussion based on that with x86 maintainers. And if they're okay with this approach, then at least like I will take on that case in ER to also think of a, you know, we need a similar protocol on the TDX side, which SVSM already defines. I mean, AMD's SVSM protocol, or at least, you know, the transport part of it. So not necessarily at application. But I would like to really wait for the, you know, for the x86 maintainers blessing. So before we proceed on that one, our side.
Yeah, right. That makes sense. So to me, it seems like a pretty solid architecture that we came up with. But yeah, nobody knows what the maintainer thinks. So, but I think it's since it's a common pattern to have a virtualization bus of some kind in a virtualized environment, as James rightly brought up before. I think we are designing it like for the other solutions, so we are not doing something completely new here. So we just extend basically the concept to the SVSM. And that makes me somewhat optimistic that the maintainers will not neck that approach. And yeah, the TDX side definitely also needs some sort of SVSM protocol, not a core protocol like AMD has, but yeah, something along those lines. So that allows
The transport part of it, at least the communication part. So that's definitely needed.
right.
So I can work on it once we have, you know, the x86 maintainers, you know, agreement.
Cool. So how many of them work at Intel these days? So quite a few, right?
Should we start to create like entry into the maintainer file about stuff related to SVSM? I'm asking you because I'm adding an SVSM file and I don't know where to put into maintainer.
Yeah, well, the question is where to start here, right? So
yeah.
So there is not only the TPM part, there's also the x86 architectural part for the AMD side. We are pretty much very early in the boot process. You have to do SVSM calls to do p validates and stuff. So this would basically also fall under some kind of SVSM maintainer entry, right? Or we limit it to the SVSM bus and its devices. That is also an approach, and keep the core part of the AMD side in the x86 maintainer's hands. Yeah, that probably makes the most sense, I think.
Right. Yeah, I agree on that.
And I think if you have like the initial implementation, like working for AMD, but still having like the generic hooks, it should be easier for us to hook into TDX part because, you know, we have less restrictions. Like we don't need to do any early calls and things like that. So it's actually, I think AMD one is more complex to kind of to do. So it's kind of a right sequence also.
So Dan asks whether Coconut SVSM is the only SVSM. There are a few others. So there was Linux SVSM from AMD, right? But that's not developed anymore. Then there's OpenHCL, which is not actually an SVSM. but Paravisor. I'm not sure if it will implement the SVSM protocol suite. And I've heard of one other experimental research SVSM also done by Microsoft.
Okay,
That's
thanks. So, but
as far as I
basically,
know,
like
not.
okay, but like the nexus of what we're talking about here would all be going into the Coconut project initially, and then seeking upstream.
Right. That I think that would be the main SVSM target to develop this against. So
Okay, thanks.
Do we have anything else to close on or discuss? It sounds like we kind of know where we're going and we know what needs to happen, at least in the immediate term. Is there anything else we want to bring up at this point or work through?
Guess silence means no.
Yeah, I was gonna say, I'm like, I can't tell if this is broken or not. I'm like, I think the silence means no, which if we want to can mean we can close early. I do want to, since we are all here, take a chance to like triple check that we in fact don't have any other like questions pending or other follow-up items people want to bring up. 'Cause it sounds like the main things are, people like Stefano and James kind of going to upstream to send out, the VTVM version and the other stuff for things that follow up. Anything else that people want to make sure happen in the next couple of weeks? If not, I think that's all we have to cover today. And thanks everyone for coming. And again, I do want to emphasize, if in the future anyone has other agenda items that they want, this agenda doc will always exist. It'll be the same Google Notes doc. Feel free to add things up in advance, particularly if you aren't able to join or things like this. And yeah, thank you all for coming.
All right, thanks everybody.
Thank you. Bye-bye.
Thank
Okay,
you.
bye everybody.
Thanks everyone. Bye.